It's great to be back here. It's always fun to come here. I grew up in Huntsville, so I feel like when I live out in Pasadena now, and so I feel like I'm almost coming home when I come here. Has anyone been when I've sort of talked the last couple of years here? Has anybody been? Couple. So usually I talk about Pluto. Last year the Pluto flyby had just happened. I showed some of the pictures from that. The year before, I think I was talking about the flyby going to happen, but talked about the general idea of why Pluto wasn't a planet and shouldn't have been a planet anymore. And I even at this time last year when I was talking about Pluto, I don't think I could have anticipated what I would be telling you about today, because we were just still in the pretty early stages of the research that we're doing, that I'm going to give you a little bit of a preview of some of the exciting stuff going on. If you'd heard it on NPR the other day, it is the search for a real ninth planet, the real new ninth planet. Pluto is not a planet. It's a tiny, tiny little nearly insignificant chunk of ice. But this thing that we are in search of is a real planet in the outer part of the solar system. I'm going to tell you why we think it's there, how we think we're going to find it, and what to be looking forward to. So the search for this ninth planet, when I think about where it all started, it probably started with the very first planetary discovery ever. The first planet that was ever discovered, other than the ones that you can just see in the sky every night, was Uranus. Uranus was discovered by William Herschel, who was carefully mapping out the positions of stars in the sky. And he would map them out, and then he would go back the next day and double check that he had mapped them in the right spot. And one of the stars that he had mapped out, it turned out to be a little bit fuzzy on the first night he looked, and he looked the second night and it had moved. A fuzzy thing moving, well, people had seen fuzzy moving things in the sky before. They were usually comets that they would see coming in. But this one was moving a little too slowly to be a comet, and it was a little bit too, it wasn't as much fuzzy as it was round. It looked like a planet. To me, this must be an astonishing moment in history that really I have never been able to read anywhere where anyone's reactions were recorded. The idea that there are planets still to be discovered. For all of human history, there were planets out to Saturn that you could see. I'm not even sure anybody even considered the idea that with a telescope you might be able to find more. And then Herschel just finds one, and it was amazing. People still argued about, is it a planet? Is it not a planet? Astronomers love this argument, apparently, and have for 200 years. And the big question that they had about Uranus is, does it really go around the sun in a circular orbit beyond Saturn? Or is it more like a comet that's on one of these orbits that comes in and then goes back out, and maybe it's not really as far away as Saturn? And the only way to tell is to track it for a long period of time and to see where it's going. So it was discovered in 1790. After it had been tracked for about 10 years, there was still a very small motion that it had moved. But after about 10 years, an astronomer in Paris realized that he could try to find it not by following it into the future, but by trying to track it in the past. And what he realized is that people had seen it before, but no one had been careful, like Herschel, who plotted positions of stars one night and then double-checked the next night, and so it moved. People had seen it, but had not noticed it had moved. So he tracked it back. He would go back a year and try to find someone who had seen it and say, yeah, that looks like that might have been it, because no one's ever said that there's a star there before. Then he'd go back about 2 more years, and there it was. And he kept on going back, and he charted all this in this beautiful paper, which is, I think, mostly exciting because I'm going to start to use his title, something like this. Here is Alexis Bouvard. He gets to say he's, Royal Legion of Honor, member of the Academy of the Bureau of Longitudes, Academy Royal of Sciences, intern in Munich in the Society of London, and the Greek Society of Science, Natural Sciences. From now on, when I write papers, I'm going to put all those things on my papers too. It makes you look much more impressive. But what he did, most importantly, is he showed, let's see, is there an actual stick that I can use to point? No, I'll just do this. what he showed, how many times does somebody come here and do this and you start to cringe? No, I won't do that part. What he showed is that if you can look, it doesn't matter if you can figure out what the numbers are, or even if you understand the math. I don't even understand the math, but the numbers, you can see he's got dates from 1690 to 1819, and little pluses and minuses at each column, and that's how far away Uranus was from where it was supposed to be. It was supposed to go in an orbit. He figured out it really does go in orbit around the sun, a circular orbit around the sun. It really was a planet. By 1820, this was the definitive proof that it was a planet. But it wasn't quite behaving exactly the way it was supposed to. It was sometimes it was a little bit ahead in its orbit, sometimes it was a little bit behind in its orbit. And what he says is something about, let's see, it's difficult to reconcile the modern observations with the ancient observations, and the most likely explanation for why there were these discrepancies in the past. So Alexis Bouvard is a nice theorist, and theorists always have good explanation for when the data in the past don't look good, and that's that the observations were bad in the past, and astronomers don't know what they're doing, and his theory is perfect. But he does say down here, there's an off chance maybe there's a planet out there pulling Uranus along. And it turns out, as we now know, the answer is there's a planet out there pulling Uranus along. Neptune is still a little bit further out from Uranus, and as Uranus was going around the sun, if Neptune is here, Uranus is going a little bit more slowly, and then it comes around here, it goes a little bit more quickly towards Neptune. And by about 1830, astronomers pretty much accepted that there was another planet out there, but no one knew how to find it. It took until 1845 when another French astronomer, Leverrier, figured out how to do the math to figure out where Neptune was. And he went and presented his results to the French Academy of Science, and they were all very impressed, and they clapped their hands and said, good job, good job. And he said, let's go look, let's go find the planet. And they're like, you can't, this is just math. You can't use math to predict reality. It's just a cute exercise. And he was like, no, there's a planet out there. But they were really, again, this is one of those moments in human history that you have to think back about how it worked. They did not have the idea that you can use theory and math and physics to actually say something about reality that you don't already know. You can sometimes explain things, but you can't really learn anything new. But so he convinced astronomers in Berlin to look for Neptune. The astronomers opened their telescope the very first night, pointed exactly where he said it was, and there was Neptune. And that was, I think, the moment when the light turned on for everybody that math and physics really work in describing the world around you. It's pretty much an obvious thing to do. Once you have discovered a planet with math and with physics, and that there are perturbations on Uranus that point you to Neptune, it's pretty obvious the next thing to do is to look for perturbations in Neptune. Make a same chart like this for Neptune that points to whatever is beyond there. And people started that in 1846, or they probably started it in late 1845. The second Neptune was discovered, people started looking for this next planet out there. And that went on for 150 years. Everybody's heard of Planet X. Planet X is this hypothetical planet that is causing Neptune's orbit to change ever so slightly. And for 150 years, people carefully calculated the orbit of Neptune. People tried very hard to do the math and the physics to figure out why Neptune was being not exactly what it was supposed to do, tried to predict where this planet X was, and they would always make a prediction, go off to the telescope, hope to be Leverrier, open up the telescope, and there was nothing there, and then go back and continue to make predictions. One time, though, it turned out that an astronomer, Percival Lowell, made a prediction of where his planet X was, this big massive thing perturbing Neptune, and went out and found an observatory, Lowell Observatory in Flagstaff, Arizona, and had astronomers start to look, and they found Pluto. Pluto is not perturbing Neptune's orbit even ever so slightly. It is tiny, tiny, and has no effect on Neptune at all. But because they were looking for something huge, and because they were looking for something approximately right here, and they found something approximately right there, it was declared a planet. And if you look at the headline from the day of discovery, the day of the announcement of the discovery in the New York Times, the headline says, new planet found beyond Neptune, possibly larger than Jupiter, and meets predictions of Lowell, which is, this is the bad part. It's like meets the predictions. Scientists in general can sometimes get themselves fooled by making a prediction and then finding something else accidentally that almost sounds like their prediction. But it's not more massive than Jupiter, Pluto. It's actually, that was only wrong by a factor of, let's see if I can get the number right, a factor of about 150,000. So it's a tiny little thing, but they thought it was out there. So Pluto really was just all part of this continued search for Planet X. Planet X finally and irrevocably died in about 1991. You still hear about it, but astronomers put it to rest in 1991 when the Voyager spacecraft finally flew by Neptune and very precisely measured the mass of Neptune. And it turns out all those times when people thought Neptune or Uranus were still not doing exactly what they were supposed to do, it's just because we had their total mass slightly wrong. So we didn't realize how much Neptune was tugging on Uranus and how much Uranus was tugging on Neptune. And when you get the masses right, there's no Planet X. Neptune is exactly where Neptune is supposed to be. Uranus is exactly where Uranus is supposed to be. There are no more planets out there, and this is about when I finished grad school was when these results came out, and I learned irrevocably that there are only 9 planets, and Pluto is the last one. Turns out we can revoke things that are irrevocable. I didn't realize that at the time. So in 1992, right after this there are no more planets out there, the first new object beyond Neptune was discovered. And since that time in 1992, there have been like 2,000 objects beyond Neptune. Here's Jupiter, Saturn, Uranus, Neptune, their orbits, so the outer planets here. And each one of these little dots is an object in what we call the Kuiper Belt. This is the same region that Pluto is in. In fact, I think Pluto is that one right there, crossing the orbit of Neptune. So Pluto is just a relatively large member of this region of space called the Kuiper Belt. All these objects go around the sun. All of them have orbits that are tilted and elongated like Pluto's orbit. And as of now, I said there's something like 2,000 of these objects out there. And we're learning so much more about the outer solar system than we had before by seeing these small objects. They're not planets. They're not anything to do with Planet X, but they're these small objects out there that we've been starting to track to learn things about. One of the early ones that we discovered back in 2002 and was this object, one of the early exciting discoveries. This object, when we found this object back in 2002, as you can see, it's a lot further out than everything else. I remember the first day we saw it, we thought, this could be a planet. This could be we've been sort of, still in the back of our minds thinking maybe there's a planet out there. So we were hoping, and we thought maybe this could be it. Maybe we have finally found this planet. What we really wanted to know is it in a circular orbit like the planets, or does it come in and go back out like a comet? We wanted to know exactly the same thing Herschel had wanted to know 150 years, 200 years earlier. And we did exactly the same thing that Bouvard did on Uranus. We actually found, we had tracked this object for a couple of weeks, and after a couple of weeks we had seen it go far enough that we could predict backwards in time where it was a year earlier. We found it a year earlier in somebody else's data. We found it 3 years earlier in somebody else's data. And we finally found it as early as 25 years earlier in some old data. With that, we could figure out the orbit. So remember, the question is it a circular orbit, or does it come in to the solar system like a comet or something does? And the answer is no. It doesn't do any one of those things. This is a crazy, crazy orbit. It goes all the way out here to the very distant part of the solar system. It takes 15,000 years to go around the sun, and it never gets close to the planets. I see some confused looks on your faces, which is good, because that was the same look that was on my face when we found it. So this is astoundingly bizarre when we first found it. It really made us scratch our heads. What it means is that probably, because it's so far away from the planets, and it goes out so far, it means that something has given it a tug and sort of pulled it away from the normal bodies that are there. We didn't know what that something was, but we knew there was something going on out there. It was very strange. I'm going to show you some of the way that we like to look at the data. It might look confusing for a minute, but you will learn to love this plot. I promise. I promise. What I'm going to show you is, I'm going to go back one actually before I show you this, just so that you know exactly what I'm showing. So one of the things that's going to turn out to be important is the direction that this orbit is pointing. So we could call that something like 4 o'clock, 3:30. So if it's pointing off in this direction, that's what that is. This is a plot that basically shows you those directions with degrees now over in here. And if you see the object that we just plotted on there, it's right here. So that's about 90 degrees from wherever north is on this one. And the other thing that you're plotting here is how far away it's been pulled from the rest of the objects in that part of the solar system. So Neptune is right here. If it's above the orbit of Neptune, the distance of Neptune, it's been pushed out a little bit. Neptune can kind of push things out to about here. If it's above this blue line, like this one is, this one's well above the blue line. If it's above the blue line, something has given it a tug. And we knew that back in 2002. And we had some crazy ideas. We suggested, it could have been a passing star had come and given it a tug. We suggested it could be a planet that used to be there that gave it a tug, or even a planet that's still there that gave it a tug. We didn't know. And you can see the orbit of it there. I've now changed the direction on you just to keep it confusing, but that's what that 90 degree means. So this is 2002. A year later, another object was found that was, it's above this blue line again. This is the key blue line. It's a little bit above the blue line. Yeah, maybe that matters. Maybe it's not. Also, notice it's just about the same direction in the hand of a clock. Interesting. 2 years later, there was another one, also above, not quite exactly the same direction, but close. Another year, there's another one. All of the objects, as you can start to see, all the objects that have been pulled away look like they're starting to have a little pattern here. Here's 1, 2, 3, 4, 5. This was in 2009. And this is 5-6 years worth of people looking for these objects out there, and nobody really, because they all dribble in once every year or so, there was never a moment when I don't think anybody ever looked at this and said, oh yeah, look at that, isn't that interesting that all 5 of those are kind of in one direction, because it's just 5. The 6th one I'm sure won't be there. Oops, but there's 2 more. 6 and 7 are not the most pulled away, but they're actually the ones that go the most distant from the sun. And what it looks like, let me put all those together. What it looks like, looks a little dark. Can you guys see these lines? Okay, so what we realized is that the 7 most distant objects, 5 of which look like they've been pulled away in some way or another, those 7 are all pointing off in one direction. Now, it's not perfect. They're not pointing precisely in one direction, so you're welcome to ask yourself whether or not this is just kind of a coincidence or not. And we asked ourselves that question, and we could calculate that the chances that something like that would happen just by accident are something like 1 in 1,000. So it's pretty low probability. So there's something happens. Something has to keep these objects also here, because if you look at these objects over about 100 million years, you'll notice that they change, like they go counterclockwise. Their positions circulate around the sun counterclockwise at different rates. So if you came back in 100 million years, they would be random again. So either we just got really lucky that they're lined up, or something is keeping them lined up. This is the point where I made a plot something like this. I walked 3 doors down on my hallway to my colleague Konstantin Batygin, who we had just hired as a young assistant professor of planetary science at Caltech, and he's super smart. So I'm like, hey, Konstantin, what's going on here? He's like, oh. So he said, you could do that with a planet. So it seems intuitive to me, and I've done this test with many other people. If I said a planet keeps these things like this, where would you draw the planet? It's a little hard because you don't have your laser pointer to draw. But think in your mind at least. Where do you think that planet is? What does the orbit of the planet look like that keeps these things like that? If you're like me, which way? Okay, where are you drawing it? We need...
Maybe closer to the sun up by those orbits.
So my guess, without knowing, was that it was an orbit, a very elongated orbit that maybe went something like this, came down like this, and it kind of hugged all of the orbits and kept them in place. And we sat down and did the math, and it turns out that's what the math suggests happens, that there can be a planet that perfectly hugs them. And we decided, we were just about to say, this is great, let's go make a big public announcement. And Konstantin is very careful and skeptical of his own stuff too. And he's like, let me just do a computer simulation to make sure that we didn't, when you do these calculations, you have to make a bunch of assumptions, make sure everything's right. Let's just do it. So here is now our computer simulation where we did this. We put this planet exactly like I said, a big elongated planet. And every one of these blue things that you can see is the loop of some orbit of some object that's starting at the beginning of the solar system. I'm going to show you 4 billion years of these orbits changing as the solar system evolves. I'm going to speed it up a little bit so that you don't have to wait for 4 billion years. And you can see that immediately the fact that this planet is here starts to move things around. Do you notice that see how these orbits are all kind of going counterclockwise? So that's the normal behavior that you would expect. And we're looking for, you can start to see objects being captured into this little spot right here, except they don't ever stick around for very long. So they start to get captured and they're gone, and they start to get captured and they're gone. These guys are still circulating around. And there's only one set of objects that sticks around. It's a little dark. I worry you guys can't see these very well. Can you see the ones that stick around? Let me see if you can see anything. Boy, it's okay. If you can't see them, so nothing sticks around in here, they come and go, they come and go. The ones that stick around are these. If you look here, there are a bunch of orbits of objects that stay in place and they're not moving like all of these are. In the end, if we finally let it go for 4 billion years, which maybe we'll stop here in a minute, what you realize is that we were 180 degrees wrong with our prediction of where this planet should be. It's not a planet that hugs the orbits of the little things on the inside. It's a planet that crosses the orbits of all these things that are on the outside too. So you have a big planet on one side and all these little objects on the other side. Totally bizarre, not at all what we expected. So if you look at, let's see if we can get it. Oops, that didn't work. Okay, this movie doesn't want it. There it goes. If you look at, here's the planet. Now I've changed them around again. The planet sits just like this, and the other objects are more or less in the same plane. They're all in one plane. They're all sort of tilted in one direction. And the planet keeps them in place by being in the opposite direction. It's a really strange behavior that we didn't understand. In fact, we didn't even really believe it at first. It took us another couple months to get around to believing what we were seeing. But the one other thing, this is the thing that for us really became the moment when we went from being the French Academy thinking this was a nice exercise to actually believing what was going on, is our computer simulations. You couldn't see it very well in the previous ones, but our computer simulations always took objects that were, if the planet's like this, our little objects are all over here, and it would always take ones that were over here, and it would tilt their orbits sideways to the solar system and sort of move them over in this direction. And it would do the same thing over here. And so it almost looked like the solar system had these wings, big planet here, funny thing on the nose, and wings over here. And perpendicular to the solar system. If you know anything about the solar system, one of the things you probably know is that the planets, the asteroids, almost everything basically goes in one disk around the sun. There aren't things that are perpendicular. So this was strange, and it was so strange that we were convinced that it proved that we were wrong, because we were predicting something that had never been seen. And it did prove we were wrong. It just proved we were wrong in that it had never been seen. After seeing these things repeatedly and repeatedly, I finally started going back into old papers that I had read many years ago. And I realized these objects were there, and just no one had ever really talked very much about them because nobody knew where they came from. There are these objects that are perpendicular to the solar system in a way that you can sort of see, can't quite see them here, but they're off in this direction and in this direction, exactly where we predicted that they were supposed to be. This is what you want to do as a scientist. You want to find something, make a prediction, have that prediction come true, and you start to believe what you've seen. So we went from being sort of skeptical, this was kind of a nice idea, maybe even true, to I am now, I think, a true believer. I'm not allowed to say 100%, but I'll say 100% believer that there's this new planet out there to be found. So this was the big announcement that we made back in January that some of you may have heard. We had to come up with a name for it, just because otherwise we would have to keep on saying the big new planet that's out there somewhere in the solar system. So after much thought, we decided the obvious name is, of course, Planet 9, and it comes with its own movie poster, which is just stolen from the Plan 9. Did anybody see Plan 9 from outer space? Why is it famous? Worst movie ever made. It is uniformly declared to be the worst movie ever made. I mean, it has Vampira and spacemen and all kinds of things. But what little known fact about Planet 9, the movie poster? So there's, I have seen it, but I can't remember the plot. For some reason, the aliens make dead people come to life. Do you remember this part? Is that? Yeah, it's weird. No one remembers. Anyway, so they're digging up something in the graveyard, and if you look really carefully, there's something written on that tombstone, which I had never noticed. Turns out it's actually R.I.P. Pluto, right there. They knew this back in no, it doesn't really say that on the real one. Okay, so we think this planet's out there, and we think it is a real planet. I mean, that's the first obvious question everybody always asks me is like, well, how do you know it's a planet? These other things aren't planets. It is something like, to be able to make all those effects that we see in the outer solar system, it has to be about 5,000 times more massive than Pluto. In fact, it has to be about 10 times the mass of the Earth. And if you find a planet that's about 10 times the mass of the Earth, it puts it right between about Earth and Neptune. That's a really fascinating range of size to put a planet, because we don't have any planets like that in the solar system. We don't know what a planet like that is, but we do a little bit. And the reason is because if now in the past decade we have found so many planets around other stars, not around the solar system, but around other stars. And the single most common type of planet we find around other stars has a mass of about 10 times the mass of the Earth. And I used to, even just a year ago, I would teach my class on the solar system, and I would talk about planets around other stars, and I would make that statement, wow, isn't it interesting that the single most common type of planet around other stars we don't know anything about. Looks like maybe we really do. In some ways, finding Planet 9 there makes the solar system seem more like the rest of the galaxy than less like it. So the nice thing about knowing a lot about 10 Earth-mass planets is that we know what they're made out of in general. Throughout the galaxy, when we find 10 Earth-mass planets, they tend to be miniature versions of Neptune, meaning that they have gas atmospheres and not a solid surface, rather than big versions of the Earth. So we don't think this is a big rocky thing. We think it's a big gaseous thing sitting out there really far away, sitting something like 10 to 20,000 years orbital period, something like 30 times further away than Neptune, really, really far away. So we need to go find it. We know a good, we're not quite as good as Leverrier. So Leverrier said, it's right there, go open your telescope, and they found it in one night. If we could have done that, I would have been retired by now, I suspect. We can't quite do that. But what we can do is we can figure out that because we see how it's affecting all these other objects and we see how it's tilting the objects, we know the orbital plane of Planet 9. And so that means if we know the plane of the orbit, that means that we know the strip of sky. I should go this way. We know the strip of sky that it goes across. But it's still a big strip of sky. It's 360 degrees around the sun that we have to look. But we don't even have to look all the way around the sun, because we know also that it's on a very elongated orbit. And because it's almost the size of Neptune, when it's the closest it gets, which is still 10 times further than Neptune, it's pretty bright. It's bright enough, if it were as close as it ever gets, it's bright enough that we could see it, clouds willing, tomorrow night from the telescope out on Long Mountain. It's at its closest approach. That's how bright it is. Sadly, it's probably going to be cloudy tomorrow night, but more importantly, it's probably not at its closest approach because it would have been seen by now. So we can actually rule out big portions of the sky where it's not, and we are left with a relatively small patch of the sky that looks something like this, which won't mean anything to most of you, but it's a patch of sky that's about this big across, and about this broad. So it's about that much sky. Seems like somewhere between not very much and a lot. And it's somewhere between not very much and a lot. What we need is a big telescope, because it's quite far away, so it's pretty faint. We need a big telescope that can cover huge swaths of sky at once. And that telescope, the best telescope, really the only game in town, is this one. This is the Subaru Telescope out on the big island of Hawaii. There's Maui in the background, you can see. And so this is the telescope that we've been spending our time at, and we'll be out there again at the end of next month looking for it with that. The reason why this is such a good telescope is because the telescope is huge. The camera on the back of the telescope, this is the camera. The camera is bigger than an anime character, and the lens for the camera is it's built by Canon, because it's the Subaru is the Japanese national telescope. Lens built by Canon, biggest camera that's ever been built for anything in the world, and it covers more sky at once than almost any other camera on a big telescope like that. So we can cover. This is, if you care about the size, here's the size of the field. This is the full moon for comparison. So it's pretty good. Covers about this much sky at once, which means that if we wanted to cover that region that I showed you, that swath of sky, it's going to take us about 20 nights on the Subaru telescope. 20 nights is this sort of middle range between a really short amount of time. If it was only going to take us 2 nights, we would have been finished by now. If it was going to take us 200 nights, we would never do it, because they would never give us 200 nights on the telescope. 20 nights, it will take us maybe 2 or 3 years to get the cumulative 20 nights with all the good weather and when the moon's not out at the right time of year and everything else. So I would say, crossing your fingers, that there's a good chance that within 2 to 3 years we will find this new 9th planet out there in the outer part of the solar system. And I want to leave you with one thought before I take any questions you might have, which is again, it's really easy to think of this abstractly, and I often think of it abstractly, and I sit around and do the math and look at the computer simulations and try to calculate the angles and where we need to do this. And every once in a while, I remember that this thing is really out there. Go out, you can, if you were a little bit too early, if you go out just before the sun comes up, you can't quite see everybody's favorite constellation yet, but in another couple weeks you'll be able to see it, which is Orion. This will be your view, your sunset view, sunrise view in a couple of weeks. And when I said there's a little swath across the sky that we're searching, that swath across the sky basically goes right here between Orion and Taurus the Bull, where they are fighting their cosmic battle in the sky. And when you do that, when you see Orion and you see Taurus out there, this is what, I mean, I have had my mind blown every once in a while to do this. Just remember, it really is out there. There is a planet that's almost the size of Neptune, a real ninth planet, really out there, sitting in the sky, right there by Orion, which you can all identify Orion in the sky, and just look a little bit above it and a little bit to the right, and it's there somewhere. And in just a couple of years, we will completely have to rewrite the astronomy books again. I should be getting royalties from the astronomy book publishers, I think. But again, because we'll be back to having 9 planets out there in the solar system when we finally find this thing. So that's the news of what we've been doing in the last year. Maybe next time I come back, I can tell you about actually having found it, because maybe we really will. Hope so. And I'm happy to answer questions until somebody cuts me off and says I have to shut up. So somebody tell me to shut up when I need to shut up, and otherwise I'll answer questions. Yeah?
The 29th on the telescope, does that data then get compared to earlier images to see what's new, or how do you tell?
So 29th, the hard part about this project is that the planet line, when it's at its most distant spot in the sky, which from the sun, which is where we think it is right now, it's almost the faintest that you could see with the biggest telescopes on the Earth. So it's really faint. It's not too faint that we can't see it, but it is right at that limit of being faint. What that means is there are no pictures of the sky that have gone to those depths that we can compare to. So we have to compare to our own pictures. So the reason it's 20 nights is because we have to take pictures one night, we take pictures the next night, and we compare those, and then we actually take a third night to double check that we know what's going on. So in 3 nights, though, we will know beyond a shadow of a doubt that that's what we saw. It's actually beautiful. If it's in so many ways, it's been almost perfect for what we're looking for. If it moved too fast, it's hard to find it the second night, because it might be that one, it might be that one. If it moves too slow, it doesn't move at all. This one moves just about the easiest amount of distance to measure. You know, if the star were here, it basically moves from here to here to here in 3 nights. If it were here to here to here, it'd be really hard. If it were here to here to here, but you'll just look at it and be like, Planet 9. So all telescopes specialize in different things. And the Subaru Telescope is big telescope, sees faint things, but it also is specialized in wide field of view, big camera that can cover different things. What I should put on here for fun, which I didn't, is the size of the biggest camera that the Hubble has, and it would be about a pixel. If you can see it, I've given this talk to some of the people at Caltech where I work, and we have a big, in fact, Caltech owns these 2 telescopes, which are right next to this telescope, and I can't use our telescopes, and I need to use that telescope, and I can't use our telescopes because even we don't have very big cameras. Our biggest cameras cover that much sky, and that's huge compared to the Hubble Space Telescope, which is going to be that. So this is 80 times smaller. So if I had to use our own telescopes, which are great telescopes for other things, it would take 1,600 nights instead of 20 nights, and that's not going to happen. So Hubble will be key when we discover it. So we have our wish list for the day of our discovery of who we're going to ask for telescope time from. Hubble will be able to see moons, if it has moons. Having moons is fantastic because that lets you weigh how much it really weighs. And it's also cool. We want to also look at it actually with those Keck telescopes. The Keck telescopes, I said everybody specializes in different things. One of the things that the Keck telescopes specialize in is taking light from very distant objects and spreading it out into its spectrum, putting it through a prism and seeing what the composition is. We'll be able to see what the atmosphere is made out of from the Keck telescopes. And the last one that we want to do right away is these huge new radio telescopes in Chile might be able to detect how much heat is leaking out of the interior of it, which will tell us a lot about where it came from, how long it's been out there, things like that. So we just have to find it first. That's a small detail. Yeah.
Is a planet so far from the sun consistent with existing theories of planet development?
So the question is essentially, how the heck did it get there? Or does it even make sense? Strangely enough, it has made sense for a decade, even though we hadn't really thought about it before. So Konstantin Batygin, who I mentioned before, who's the one who I work with on this, what I didn't mention before is that he was a graduate student at Caltech before he became a professor at Caltech. And when he was a graduate student, I was his PhD advisor. And we let him have a PhD because he's smarter than all the rest of us put together, so that's easy reason to give someone a PhD. But one of the things that we did when he was a graduate student is we started working on the idea that perhaps early in the history of the solar system, there were not 4 giant planets, but there were 5 giant planets, all close together: Jupiter, Saturn, Uranus, Neptune, something else, all packed in pretty tightly. And that as the solar system evolved, they got a little bit too close, and one of those got ejected. And it actually explains a lot about what we see in the solar system now, if there had used to been this 5th planet. And so we thought, oh, this is a great idea. Wrote a few papers, talked about it some. What we never thought about is what happens after it gets ejected. We just kind of thought, it's gone, it's never to be seen again. It's a completely natural, though, once it gets ejected, that it goes off into this very distant, very elongated orbit. So as soon as we realized that it was about 10 times the mass of the Earth, which is exactly the mass that you would think for this 5th giant planet, and that it was on this very elongated orbit, tilted by about 30 degrees, we're like, this is the planet we talked about a decade ago. So it fits perfectly with what we think we know about the solar system. Doesn't mean it's true. So that's the sort of speculation part. The evidence that we have that the planet is there doesn't care about how it got there. All I can tell you for sure is it's there, and then we can start to make up stories about how it got there. I think this is probably true, though, and once we find it, we'll be able to answer more of those questions. Yeah?
You mentioned a point closest to the furthest from the sun.
Yeah.
That elongated orbit. What with that elongated orbit allows you to consider it still a part of the solar system if it got ejected as well?
So it goes around the sun. So that's the answer to the question. It's still, even though it looks really far away compared to the other planets, it is still very much part of the solar system. It goes around the sun. It takes 15,000 years to go around the sun, but it still goes around the sun. So it's still part of our solar system. There are things in the very distant comets that are part of our solar system that are a factor of 10 and 100 times further away still. So our solar system goes really quite far away, even though we never really think of it that way. We kind of think of the 8 planets and then maybe some stuff a little further out there, but it's really quite big. We just didn't realize that there were other large objects quite so far away.
Sorry, what about all the other things that orbit the sun in some way that we don't consider like planets or?
So there are all those other things. So all these objects, like the objects in the Kuiper Belt that I talked about, asteroids, all these other things, all of these things go around the sun. They're not planets. So there are the 8 planets that we know about for sure, and this would make the 9th one. But then there are thousands and thousands, millions of these small bodies, asteroids, Kuiper Belt objects, comets, also going around the sun, also sort of flitting in and out of the orbits of the giant planets. You can think of them as kind of the debris left over after the planets in the solar system formed. There was still just some junk that's very slowly getting cleared out of the solar system. But it's still all very much part of the solar system on very regular orbits, and they're sufficiently regular orbits that they're the ones that we use to show us that there must be something there, because they're doing things they shouldn't be doing otherwise. Yeah.
Why do they stay in a regular orbit? I mean, it seems like they'd be changing, and the gravity or magnetic force. I mean, why? How can they just keep doing that?
Yeah. So as you saw from that movie, maybe you couldn't see, they don't all stay. So what the soul and that story that I just told you about, maybe there used to be 5 giant planets in the outer solar system and one of them got ejected. Also, they didn't stay. They've all rearranged over the course of 4 billion years, and potentially some of them have been ejected. It's possible that there were even more planets to begin with that have gotten ejected. What we see now is that the things that we see, the 8 planets, the small bodies that are around there, these are the things that have survived for 4 billion years. So they are the things that are mostly stable and will stay more or less in their same positions forever now. Because if they were going to be moving very much, they probably would have done it already and gotten ejected and moved around. So, it's kind of a long period of sorting itself out, but now they're more or less going to stay. So basically what happens is that the planets make sure that they're far enough apart from each other that their gravitational pulls don't affect each other too much. They do some, they always do, but not too much. So we, as we go around the sun, we are affected by every other planet in the solar system ever so slightly. Our position changes all the time, but on average, we still go around in our perfect once a year kind of thing. Yeah.
Is there an equivalent with the French Academy of Sciences in the story who are sort of saying, well, this looks like a very nice opportunity to find
So the part of the French Academy is now played by just wisely skeptical astronomers everywhere. So the French Academy didn't even think you should look. So that's the difference. Today, I don't think anybody would say, well, no, there are definitely people who say, no, you're just wrong. Don't go look. So the people who would say you're just wrong would argue that, there are those 7 objects that are all pointing off in one direction. They would say it's just a coincidence. And it's a not unreasonable argument to try to make. The human brain is spectacular at finding patterns, faces on Mars, Jesus on toast, that kind of stuff. This is what we're good at. And so it could be that we just made up a pattern in our heads and convinced ourselves that it was true. And then after the fact, you can kind of construct an idea of why it's there. I'm pretty sure it's not true. And the reason that I worried about this for months. And for me, it took that moment when we realized that there were those perpendicular objects that we predicted. That's when it went, for me, this is not just, a face on Mars. This is for real. But everybody wants to be skeptical because that's what scientists do best. And no one will believe that it is for sure real until we actually get an image of it. 99, I don't know what my fraction, there's so many other little things that Planet 9 now explains that we didn't even think about at the time. Dumb little things like, the things that nobody knows. The sun, the planets are all in one disk. The sun is tilted by 6 degrees to that disk. Nobody understands why, and it's so ununderstandable that nobody even talks about it. So is anyone in this room even know that was true? Other than you? Yeah, okay, 1 person, 2 people. So, turns out the reason why, actually Planet 9 does it. It's not that the sun is tilted. Planet 9 goes out and tilts the solar system and leaves the sun in place. And you can predict exactly how much it would do it, and you get exactly the right answer. Again, something we didn't even think about when we first started doing this. So there's so many things it explains. If if it's not true, it's one of these cases of nature really conspiring to make us look stupid, because it's doing a really good job of making it look like it's true. Why do they all orbit in the same disk? So all the planets orbit in the same disk because they all formed in a cloud of gas. So there's a big gas cloud in space, and it's spinning just a little bit. And as it starts to collapse, there's gravity from all the mass. As it starts to collapse, it starts to spin faster. The analogy that you are contractually obligated to always use is the figure skater pulling in his hands and spinning faster and faster and faster. So the gas cloud, you pull in, the gas cloud spins faster and faster, and it basically squashes down into a pancake as you spin faster and faster. And the objects all form in that pancake in a very, very thin disk of material. And so things are within a degree or two, everything is all in one disk. So when you see things that aren't, like Planet 9 is tilted by about 30 degrees, unlikely that it formed by this process. So we think it formed in the disk like everything else, but then got kicked out there. All these other objects, comets, asteroids, Kuiper Belt objects, which are on these crazy orbits, again, it's because they've been kicked around by the planets, who are the big bullies of the solar system.